So today we're going to talk about the atomic structure EQs that you worked on. So please make sure you have your EQs out in your notebook ready to go as we talk about each one. So we're going to start out with a discussion of an atom. An atom is the smallest part of an element, so it's the smallest part that you can get to that's still identifiable as a specific element. There are smaller parts within an atom, but the difference being that those parts themselves are not identifiable. So an atom is to chemistry as a cell is to biology. So if you remember, a cell is the smallest unit of life. You can divide a cell, but once you start picking it apart and picking the nucleus out, etc., it is no longer a living thing. So the basic structure of an atom is that you have the nucleus in the center, and that contains the protons and neutrons, which are two particles of an atom. And then around the outside in these rings, which we're going to call orbitals, are the electrons. So electrons are on the outside, the nucleus is the inside, and the nucleus is made up of protons and neutrons. Some other basic information you want to know about the particles that make up an atom is you want to know their charge, their basic charge. So a proton has a charge of +1, an electron has a charge of -1, and a neutron, kind of like the name suggests, is neutral or has a charge of 0. And what happens in most atoms, or what we call neutral atoms, the number of positive protons is going to exactly equal the number of negative electrons. So you can see in this example, there's 1, 2, 3, 4, 5, 6 protons, and then there's 6 electrons. So when you do +6 -6, you get an overall charge of 0, which is neutral. So unless it is a specific type of an atom called an ion, the protons and neutrons and electrons are going to be the same. The relative mass, so remember this is relative, this is not actual mass, it's not 1 gram, is that a proton is a 1, a neutron is a 1, and an electron is very, very small. We say it's 1/1800th that of a proton. Sometimes you're going to see this as an electron has a mass of 0. The only problem with saying the electron has a mass of 0 is that it wouldn't be matter. Because remember, matter is anything that has mass and takes up space. So really, it's just really, 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 really small. The location within an atom is going to be, again, the nucleus is where the proton and neutron are, and the electrons are orbiting around the nucleus. So the way that an atom can identify a certain element is actually by the number of protons in its nucleus. So the number of protons in the nucleus of an atom gives the atom its identity. So if we look here, a hydrogen, that's a type of element, is a hydrogen atom because it only has 1 proton. Anytime you see an atom with 1 proton, it's always going to be a hydrogen because that's what identifies it. If we look over here, carbon has 6 protons, nitrogen has 7, and oxygen has 8. So the number of protons never changes unless you're changing the identity of that element. So if you have an atom of hydrogen, it's always going to have 1 proton. Notice in the cases listed here, the protons, neutrons, and electrons are all equal. You see carbon at 666, oxygen's 888. That is because these are all neutral forms. So in the atom's neutral forms, the protons, neutrons, and electrons are equal. Now, the protons, remember, always stay the same. The neutrons and electrons can change, and that can result in a different type of that element, but it's still the same element. So it's only the protons that identify the element. So those two ways that you can have a different type of atom, still be the same element but a different type, are isotopes and ions. So they're two different things. Remember that the number of protons has to stay the same. That cannot change. If you change the number of protons, you change the identity of the atom. An ion is any time you have a change in the number of electrons. So that is where the protons and neutrons will be the same. The electrons will be different, and that is called an ion. The ions can be negative or positive, meaning they can have more or less electrons. But anytime that electron number only is different, it's called an ion. An isotope is whenever you have a different number of neutrons. So that is where, again, the protons will be the same. The electrons in that case will be the same, but the number of neutrons will be different. So with ions, what's going to happen is you're going to have a charge on the element. You can see here it has a -2. And an isotope's going to have a different mass. Because remember, neutrons only contribute to the mass of the element. So why do isotopes exist? Why do ions exist? They both exist because they have slightly different chemical and physical properties than their stable forms. You're going to be able to do different things with isotopes or ions of each element. So an example of that you see here, these are 3 isotopes of carbon. What I want you to notice first, like we talked about, it is carbon. Carbon has 6 protons. Notice they all have 6 protons. Because if you change the number of protons, you change the identity. It's no longer carbon. So because these are isotopes of carbon, they're going to have 6 protons, 6 protons, 6 protons. And then notice on the bottom, there's differing number of neutrons. So in this first one, carbon 12, notice the protons and neutrons are the same. So we consider this atom stable. And it's basically used for the building block of all life. Those are the properties of that one. Carbon 13, you see here, has 1 more neutron. So it has 7 neutrons and 6 protons. This one, again, is stable. And you can use it for a breath test for bacteria. But if you go over here to carbon 14, 6 protons, 8 neutrons, this now is radioactive. So the stable form of carbon, normal, stable, doesn't do anything to you. It actually is necessary for life. But you add 2 more neutrons, and it actually becomes radioactive. And carbon 14 is one of the things we use to radiodate fossils. So again, the properties are going to change when you have an isotope or an ion as well. So where are you going to find some of this information? Remember that the periodic table is going to be your key. That's going to have the atomic number. It's going to have the atomic mass. It's going to have the element symbol. Another way that you can write it is if you have the symbol here for X, this would be the element symbol. The top number here is called the mass number, and the bottom number here, Z, is called the atomic number. So this Z atomic number comes from the periodic table, always, 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 always. And that number always, 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 always equals the number of protons. Don't forget the number of protons cannot change. So you will always find the atomic number, usually on the top part of a periodic table square. The mass number you actually usually don't find on a periodic table because a mass number is for a specific element, most of the time an isotope, and that tells you the exact number of protons and neutrons in that specific isotope. So mass number is different than atomic mass. You will find atomic mass on the periodic table, that's an average. Mass number you will not. This is for individual elements. So looking here at a sample periodic table square, remember you always have a periodic table to use. What you're going to be able to find is usually the atomic symbol, sometimes the name as well, but almost always the atomic symbol. Towards the upper side, either in the corner or in the middle here, you have the atomic number. That symbol is Z. So this number here always, always, always equals the number of protons. You will often find at the bottom the atomic mass. Notice that's not the mass number. Atomic mass and mass number are 2 different things. Mass number is the total number of protons and neutrons for an individual element. Atomic mass is the average of all the isotopes, all the different types of atoms that exist for this element. So you see here, it's the average mass of all the isotopes. That's the atomic mass. You will find the atomic mass on the periodic table. Notice it has a decimal, which should kind of give you some hint that it's an average, whereas mass number is going to be a whole number. And then, again, here the element name is up at the top. Again, there's 2 different types of ions, a cation and an anion. So a cation is a positive ion, an anion is a negative ion. You can maybe remember that, like anion's kind of like an onion. Onions make you cry, negative. The way you make a cation is you have more protons, more positives, than you have negative electrons. So look, you have 1, 2, 3, 4, 5 positive protons, that's plus 5. So if you write that, you're going to be plus 5. And then you have 1, 2, 3 negative electrons, that's minus 3. So if you add those together, your overall charge is going to be plus 2 or positive 2. An anion is going to be the opposite. You see an anion has 3 positives, so it has plus 3, but it has 1, 2, 3, 4, 5 negatives, minus 5. So plus 3 minus 5 is going to give you a negative 2. That is where the anion comes from. So think about it like this. Since electrons are negative, think of them like bad negative people, right? Whether it's a significant other or a friend. If you have a bad negative friend in your life gets more negative. So the more electrons you have, the more negative you are. If you get rid of that bad friend, your life gets better, becomes more positive. So when you lose electrons, you become more positive, you become a cation.